Okay. So today what we're going to do is talk about add and subtract, multiply, divide proofs. These are going to use the add and subtract property and the multiplication and divide property. We're going to see how that works. This is day 4 of unit 2, sections 2.5 and 2.6. All right, so looking at these diagrams, we're not writing proofs at this point. Let's look at part A and B and tell which segments we could say are congruent by the addition property. Tell your neighbors which segments or angles can be named congruent because of the addition property.
Oh.
Okay, what do we think about part A? Which segments can we say are congruent by the addition property? Yeah. AD congruent to AC. Now look at these markings mean congruent, right? This segment's congruent to that. This segment's congruent to that. Therefore, when I add congruent segments together, I get congruent segments. Raise your hand if you know what I can say is congruent in part B. Yes. Which ones? Say it one more time. Mm-hmm. Good. That's because I have congruent angles. These two are congruent. These two are congruent. When I add congruent angles together, I get bigger congruent angles. These are both true by the addition property. Okay. Now, if I look at A and B for the subtraction property, they look very similar, but instead of starting with big segments, instead of starting with small segments and getting large segments, in this case, I'm starting with larger segments and getting smaller segments. So what can I say in part A? What segments are congruent by the subtraction property? Yes? No. RS is congruent to TV. So if I look, I have this segment and that segment congruent, and I am subtracting ST from both of them. Subtraction property. Okay. Now in part B, I have these larger angles and the smaller pieces. I'm subtracting the smaller pieces, and I would end up with ZXY congruent to angle DBC. When I subtract, I start with big angles, get small angles. If I'm adding, I start with small angles, get big angles. Make sense? Okay, good. All right, so now let's look at a proof that would use one of these. Okay. The first thing I always do in any proof is mark my diagram. So it says PNO is congruent to PON. And I usually mark it like that just to indicate that it's that entire angle. Then I'm told that ONX is congruent to NOX. And I'd like to prove that angle SNX is congruent to ROX. Raise your hand if you know what property will allow me to do that. Yeah, Jonah. Subtraction property, that's great. So the difference though is I'm going to write a 2-column proof. And I have to say my givens. and ONX congruent to NOX. Do you see how marking the diagram helped a lot? If I'm reading this, it doesn't, the visual of what's congruent is extremely helpful. So make sure you are marking your diagram appropriately. This proof is super easy. All I need are the givens. And then I'm ready to prove the statement. Angle SNX is congruent to angle ROX. And that's true by the subtraction property. Right? I'm starting with these big congruent angles. Then I'm subtracting congruent angles from each. What I'm left with have to be congruent.
So like, wouldn't you have to say like assume from a diagram to say that like XNO plus NNX equals SNO
You
or PNO?
you could, and in average geometry would make them do that, but you can see it from here. Okay. No. And the thing is, what's going to happen is our proofs are going to end up being quite long. Trust me, you're not going to want to do that. Okay. Subtraction property.
Oh, you don't have to like explain it.
No, subtraction property. All right, next one. Why don't you give this one a try? Try this one. 2 count. Right, 2 count proof.
We'll need to do a flow diagram on the test.
At some point, sure. But for the most part, we're gonna do the 2 count proofs. I'll prepare you though. Okay, here is my answer. Now, you likely left off step 2, right?
See, yes.
Okay. Now, there are some steps you can skip, like I don't need to say that TW is equal to TV plus VW, although I do know that it is. But if I'm going to use the addition property, remember the addition property says if I have congruent segments and I add congruent segments to those, I end up with larger congruent segments. In order to use the addition property, I need to specify which pieces are congruent that I'll add together. So I'm going to add VW to TV. And when I do that, I end up with TW. And I'm going to add WV to WX. And when I do that, I end up with VX. So we need this statement in there. That is the reflexive property. Remember, reflexive means that anything that I state is equal to itself. That's the reflexive property. Do you guys have questions on that?
Did you use the AFD instead of reflexive property?
No. AFD is I look at the diagram and I can assume a straight line or something like that. I'm not assuming from the diagram that VW is equal to VW. It is because of the reflexive property. And do you see how I switched the order of the endpoints? You don't have to do that. And actually, I'm kind of surprised I did that. You could put VW is congruent to VW. Addition property. Because that's what I'm adding to each of these.
Oh.
All right, does everyone understand why that reflexive property is necessary there? Okay. Here is yet another one. Wide, you know what? I'm going to do this one with you. All right. So it's, let's mark our diagram. KMR is congruent to VTW. KMR is congruent to VTW. MR and MP trisect KMO. VX and TW trisect angle VTS. And I would like to prove that these are congruent. What property is going to allow me to do that?
Division,
No,
subtraction.
multiplication property. Okay, I'm taking each of those angles and I'm multiplying by 3 to get the larger angles. Multiplication property. So it's going to look like this. Angle KMR is congruent to angle VTW. That's given. MR and MP trisect angle KMO. That's given. TX and TW trisect angle VTS. That's given. And I can go straight to what I'm trying to prove. KMO is congruent to angle VTS, and the reason is multiplication property.
Oh, this way.
Since this is trisected, I know that I can multiply each of these by 3 and get the larger angles, multiplication property. Yeah, wait a minute. No, I know what that means. I know what that trisection means. So do you. So does our reader. Yeah, what was your question? Okay, our reader knows all the vocabulary words that we've learned. Yes. If you want to use the addition property, you would have to say RMP is congruent to WTX, say each piece of the congruent angles, and then sure, you could use addition property, but it's longer. So. Okay. Why don't you try this one? All right, here's my answer. Really, you're just listing all the givens. And then we're going to the division property. The pictures are the same. Please stop talking while I am. The pictures are the same. The difference here is that I'm starting with the larger angles and I'm making a conclusion about the parts. Okay. When I trisect, if I start with the larger pieces, I can divide that and divide each by 3 and end up with the smaller parts. So this is the division property. Questions on that?
No.
So now it is time to practice, and I have put the problems I want you to do out online. Practice makes perfect.